All right. Welcome back to the Data Patch. Data Patch with Don. Morning, Thursday, November 4th. And today's subjects will be a little bit more charting. I wanted to cover, there's almost nothing in that book about scatter plots, like almost nothing. So I wanted to at least create one and show you some of the different um, chart elements. And what I was trying to come up with, the word, let me share my screen. The word last time, let me pull up one of these. Um, let's see. Yeah, this thing, am I sharing my screen? I'm not. Share your screen. Share. Coming up. Cool. You guys got my screen?
Yes, sir.
Sound check good. Got it. Okay. So when you click in a pivot table, remember Excel is context sensitive to the nth degree. You click in a pivot table, this thing over here to the right. Um, and if you click on a chart area, remember I was trying to remember it's a task pane, a format task pane. That's the term that was eluding me, that was bugging me last time. So when you click on this or you click on a chart or whatever, and you get this thing over here, this box on the right, that's a format task pane. Actually, this one is the pivot table field pane, but it's a pane, Pane. Okay. So today I wanted to start off with scatter plots. And remember, scatter plots are how you look at the relationship between two continuous variables, normally, just numbers like, you know, longevity and blood pressure, or blood pressure and cholesterol, or in the case of a file I was able to find real quickly on the internet, Googling is wonderful. If you just want to find something out there, it's just amazing. But I pulled up a very small, nice, compact data set off of, I think it was a Seattle, Washington Community College. Where did I find this? Real data. Whatcom Community College. And then I went to this one, which is actually, I believe, at seattlecentral.edu. So it had all of these cool uh, data sets. And this was just very simple. But it was when I Googled, data for a scatter plot, I found this Whatcom Community College, and it had all kinds of cool data sets. So, like I said, when we do this applied um, data storytelling, you know, dealer's choice. Y'all pick whatever you want to mess around with. There's just no end of data out there to mess with and practice these different um, techniques. Okay, so this is your raw data for a scatter chart. What we've got is potassium and nitrate. I think this is from a water test at a broiler farm, which is actually coincidentally, I'm meeting at 1 o'clock today with a couple of IT guys they're going to be apprentices, but in system administration and network administration. But they own a broiler chicken farm, so they pop out, the chickens that we all know and love by the cajillion. So it's a livestock production data analytics sort of exercise. Um, and these guys are the ones behind the scene with the systems, administering the systems. So a scatter plot. In here, we would select our data. I just go ahead and actually, if I click in that table, I made this a table. The range from cell A4 down here to B16. I went ahead and selected them and did that insert table. You see how it's grayed out because it's already a table. But it wasn't when I first got it. It was just a flat file like this. But this header data tends to confuse Excel up here. So if you see something like this that has explanatory, descriptive information in the worksheet, to prevent Excel from getting confused, I recommend you just select it and say insert table, just regular old table. And you get this format here. Now, it seems like if we just say insert, and I know I want to do a XY chart, scatter XY, because we have two variables. So let's do a good old scatter. Okay, boom. So I'll make this much bigger. And, of course, by default, it goes as an embedded chart floating on top of your workspace. So we don't have a whole lot of data points here, of course, but that is your basic scatter plot. Along the x-axis here, from 0 to 2, it auto scales the axis. It looks at the range of the data and uses that as a good guessing point as to where you want to bound your data. Outliers will tend to stretch it out and kind of make it where, because you got to make room for all the data. So it can tend to goof it up a little bit compared to how you might like to see it. But anyway, you can
Hey,
already.
Don.
Whoa. Yes, ma'am.
Sorry, you're breaking up every couple of minutes and it kind of goes in and out.
Yeah, doggone it. Same thing as yesterday. Is it bad enough to take a 3-minute break and plug in my cable?
What's happened? It sounds like someone's putting you on pause for
Yeah.
about 15 seconds, and then
Oh,
you
that's a
come
long
back
time.
and
That's a long
Yeah.
time. Just check your email, whatever. I'm gonna plug in my Ethernet cable and get off Wi-Fi. So I'll be back here in just a minute. If I get booted, just stay here and I'll rejoin. It'll probably auto assign one of you as a host or something like that. But yeah, just give me 3 minutes. I apologize. All right. Well, I apologize for the technical difficulties. Let me go back to what we were talking about. Share screen, whole screen, nothing but the screen. Okay, back to S058. So somebody let me know, did the insert scatter plot and talking about this thing being a table, that came through, right?
Yes.
Okay, that's just generic. This is what you first get, is a scatter plot, and it defaults to something that you'll see some stuff here that isn't what you might want to see. For one, it defaults the chart title chart element to the column title, and that's not what it is. This is like groundwater testing at broiler farm. So you gotta click in it and modify, edit that chart element. And then you also start to notice that we don't know what 0 through 2 is, and we don't know what 0 through 30 is. So the chart isn't particularly meaningful. So remember, for any chart, if you want to add or subtract one of these elements, one of these things on the chart, you click that green plus sign up here, and you get your chart element selection box. And you'll notice there are no axis titles right now. And it previews, you hover your mouse pointer over it. I'm not clicking on it yet, but it shows you that it gets 2 axis titles. But I'm curious, I didn't go this far before. So there are even more things to primary vertical. Yeah, that's cool. As far as which lets you know which axis you're dealing with there. But I just want axis titles, and then I will click in them, and we know that that this is looking at the data. This left hand is the nitrate. So let's modify that title, and I got to hit the up arrow to go up, which is actually right, and then the backspace, not the down space, to get rid of what's in there. So we know that this is nitrate, and I don't need to put the milligrams per liter, but just an example here. And then down at the bottom, we know that this is potassium, made in Kazakhstan, greatest country in the world. That's a Borat reference if you haven't seen the movie Borat. All other countries are run by little girls. Okay, so there we've put our axis in at least, but the scatter plot, the whole reason to generate a scatter plot is to analyze the relationship. So you probably want to add a chart element, and again, not all charts have all the same elements to choose from. But we probably want to add a trend line here, a trend line. And I wanted to show you down here at the bottom that it defaults to your good old fashioned linear equation straight line that is the best average fit between the dots. So there it goes through an algorithm and averages out where the distance between the dots would be, and it puts the line of best fit is what that trend line is called. But you don't have to just do linear, because sometimes data, it correlates, but it's not a linear correlation. It could be logarithmic or exponential, and there's, like I said, that's where you start getting into Hunter's math degree and statistics course and all that. But I just wanted to show you that there are different kinds of trend lines here that you can look at that will do a line of best fit according to that technique. So we have linear that we saw before. That's what it defaults to. But then you've got this exponential line of best fit, which some data is exponential. As it increases, it gets I think it's called asymptotic to one of the X values, and it can't ever get past that. And no matter what you do, it just keeps going up in Y, but it never goes any further to the right. And then you've got, I thought you had logarithmic, but I don't want to get too far into the math here. So that's a scatter plot, and with these chart elements. But so let's go ahead and add a linear line of best fit. And then click outside, and I wanted to, and I didn't have time, so I am gonna experiment right in front of you. Be careful, Don. So our line of best fit here, we click on it. I want to show you that you can add the equation, which is the y equals mx plus b rise over run, that whole mathematical equation. But I'm trying to remember where I do that without having to Google it. Does anybody remember? Has anybody done a trend line here recently? And seen where you can add the actual mathematical expression that the equation of that line? Anybody? Trend line options. Seems like it's there. Yeah, it's under because not every element is the same, and when you click on, not every chart is the same, not every chart has the same elements, and not every element has the same formatting options, because they're not all the same. This is where the trend line options, the rest of these are kind of generic, like the fill color and whatnot, and the but when you start seeing the rightmost symbol here on the format pane, it very often is unique to that kind of element. And this is where you see the formatting options that are unique to a trend line, or at least specific to a trend line. So this is what I wanted to show you. So this is the equation on the chart. Y equals 9.5x plus 4.8. And that equation of the line is how you do linear regression. You would say, okay, well, what happens if we get a 3 of potassium, and mathematically it would give you the exact guess as to where your nitrate would wind up if you had a 3 of potassium, kind of projecting along that line. And there's other ways to do to insert the randomness of the data or the nature of the data in that, but that's basically how that works. So yeah, not every chart element has the same formatting option. So you just kind of got to get used to working with these different ones. And you can also put the R square, remember, R is from -1 to +1. And if you're looking at the camera, the slope of the line is, positively correlated would be a positive R value, but negatively correlated if X goes up and Y goes down, that's negatively correlated. But generally speaking, you square that to get rid of the negative so that it's always a positive value. And then they use R squared in follow-on formulas and techniques. And that is our square value on the chart right there. R squared equals. So you can click on those and add them to the chart. And then to get rid of an element, you can either click on the plus sign, or you can just click on the element if you wanted to get rid of that that trend line. So we click on it, and it's highlighted. You can tell because it's got the circles at the end. And then if we delete it, I think it takes away. Yeah, it takes away the equation and all of that. Then there was one other thing. Let's see if I can. Yeah, I wanted to show you that, how we've talked about the x-axis, this horizontal potassium axis is your independent variable. It's what happens no matter what, and we're looking for it to cause a change in the y-axis. So as x goes from left to right, what is the corresponding change in the nitrate? But sometimes if you get it backwards and you're messing with something and you're like, no, what was I thinking? And you just want to switch it. I think switching column and row here under the chart design tab, switch column and row seems like it will pop potassium over to the Y and nitrate down to the X. Let's try it. No, that ain't right. There was a way to switch X and Y. There was a way to switch the X and the Y. See, now I'm going to have to go back. I've done it before. I think I did it on this, what do you call it? Does anybody remember how I did it? If I wanted to switch potassium to the y-axis and nitrate to the x-axis. I can't remember either. Maybe it's in the data? The data tab? I'm gonna have to look again. Anyway, there's a easy, quick, quick mouse click of the mouse that will change your x and the y axis if you get going wrong in the wrong direction with your scatter plot. So that's creating it from scratch. And of course, this neat little data set had one that they'd created in its own chart tab. This is not a worksheet tab, it's a chart tab. And they had, of course, they'd changed the chart area, the charting area to a different color, and typed in the titles and changed the fonts and made it pretty and whatnot. So there you go, scatter diagram. Okay. So I wanted to also go into what's called a pivot chart, which is a chart that is derived on a pivot table instead of a normal data set. Give y'all a look at that. Any questions on a scatter diagram, on their use, on the theory? During the break, I'll look at how you flip that thing around. Okay. Seems like everybody's okay. Okay, get rid of that one. And then a pivot chart. I was messing around with those in the good old bank accounts file in your textbook data set. Okay, so pulling that up, and you can follow along here if you'd like to. Just pulling up bank accounts. So pivot charts are really not really any different than regular charts. It's just that they're based on the data in the pivot table, and you don't have to go back and reformat. You know what I mean? It takes what you've done in the design of a pivot table and springboards the creation of a chart that's based on that pivot table. So pretty slick. And you know, this pivot table was created with you got a row for each branch. So that's down here in we drag that down into our rows section. And we've got a column for each type of bank account. That you drag that down into your column. And then the meat of the data inside of our pivot table is the sum of amount. And I'm clicking on these down here in the lower right-hand corner. Remember, we could do a count, and that would tell you the number of these types of accounts. But if we do the sum of the amount, it tells you how much money was initially deposited. So that's what we've got in this quick little pivot table, just as a refresher. And I'm on sheet part 1. So if you click in the pivot table, you can then insert a pivot chart, and it automatically guesses based on your data what kind of chart you might want. So yeah, clustered column, that looks right. You know, the dollar amounts going into so we'll select that one. That looks right. Let me stretch it up a little bit. Get rid of my task pane. So yeah, we've got a bar that is the cumulative total of dollar amount that went into each of these types of accounts over here on the right. And you'll notice some differences in this clustered bar versus a normal one that you create. And that's mainly is these filters here. These auto filters. So if we wanted to, we could get rid of what's the gray one? That's kind of IRA. That's kind of tiny. That's not really affecting much. So let's say I don't really care about IRA because it's not a significant factor. So we click on that and it disappears from the chart, and it disappears from the legend. Yeah, these pivot charts are slightly different than a regular chart. So we can put that back in there. And there's other types, you know, of course, always. If you go back to insert, let's kill that one and go back to clicking in the pivot table and clicking insert pivot chart. There's others like, you know, my favorite two to compare is a clustered column, which shows them side by side. But you can't really see the effect on amount. But if you go to a stacked column, now we can see, make that a little bit bigger. Now we can see that there's $3 million in deposits at the central branch, but only a little over 2 million at North County, and what million and 1.3 million at West Side. So that stacked column lets you show the relative contribution of these things. And just like before, if you are in one of these and again, the IRA maybe is just distracting, so you want to pull that out. It does the exact same thing with that chart type, just pulls those out and reformats the legend, and off you go. So that's one way to add. You see how it's starting to be interactive. So when you move from the raw data as an analyst, which is this stuff. So if your boss wanted to know, hey, show me the data of how much you're being deposited and different accounts, and the employee type, which kind of are we talking the new accounts folks over at the desk, or the teller, or up at the teller window, and oh yeah, by the way, I want to know if they're new or existing customers. So your boss asks you for that, and you go, okay, and you go pull this data out of the system and hand it to them. That's the raw data. So yeah, of course, right, because your boss can't play with it necessarily, and so you need to start making it a little bit more useful, and that's what charts and pivot tables and things like that are for. But the interactivity, that's really what everything seems to be going to, is this self-service data analytics, where it takes a business intelligence developer, an analyst to set the thing up. But after that, if they want to, if management wants or needs the data in a slightly different format, there was a time when the analyst had to absolutely recreate that themselves every time. And now you're getting to be where it's just more and more and more and more easy for management to figure it out for themselves, to just monkey with the data themselves to get the information they're looking for. So I wanted to make that point about pivot tables. Go back to pivot table part 1, PT1, pivot table 1. And it's starting to be self-service, where a pivot table adds these filters automatically, but sometimes they're not quite as intelligent as you might, or they're not quite as useful as you might like. So there's a thing in here that you can add. 907. Yeah, and I'll finish with this. There's a thing that you can add. Kill this chart so I don't clutter up my screen too bad, called a pivot table slicer. And where is that pivot table? Insert. Is it under insert slicer? Yeah, insert slicer. So this is sort of the dialog box that you use to build a slicer, and a slicer is just a good-looking filter widget that lets the user filter the data. So here we can do, let's say we want to give them a slicer by account type and branch, and I'm going to do another one of these after the break, so that it would uses more data. Okay, account type and branch. So what we get when we say that are these cool looking boxes. And they're auto magic, and you can line them up and make them look real pretty, kind of like a dashboard. And you can see now that it sensed that I had already filtered out IRA, but it knows IRA is one of the data points. So if we click on that, it brings up just IRA. If you hold control, just like any other Windows object, if you hold control, you bring them all back in, click, 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 and it's as if the slicer isn't being used for anything. And you can also slice by branch. So if you just wanted to limit the data down to just the west side, you click on west side. Ah, there you go. Now I just want to look at the central. Click on central. So it's an interactive widget that you can add to a worksheet, to an Excel spreadsheet, so that the user can just click on a button without having to worry about what to drop down and whatnot. So yeah, pivot table slicer. I'm gonna go ahead and finish out what I'm doing here with pivot tables and these charts and pivot table charts. And then we'll break, and then we'll bring up Python Notebook 4. Let me make sure I publish that in the classroom. It is published in the classroom. You've got a Notebook 4 repetition statements or looping. So I wanted to go ahead and go over that so that we will have seen, it takes a lot of practice to get anywhere near confident with them, but you will have seen these three basic computer science structures, just sequential statements, conditional statements, and repetition or looping constructs. But for now, I had a start to finish thing here. Okay, pivot table slicers is a file in your textbook data files. Pivot table slicer, and that's what I'm using. But I went into the sales worksheet, and I cut out the data, or I copied it and got rid of the pivot tables and the pivot chart and the slicers and whatnot, and copied it over here to raw data. So that's all I'm doing here, is just recreating what they had done step by step. So somebody gives you, now let me draw the Hunter, Leela, Jasmine. If I remember conversations with you before, you guys kind of design stuff, reports based on user request, right? And then someone else implements it in a tool. Did I get that right?
I've created like the high level designs for reports, and then Hunter is the one that actually goes in and builds it and makes the magic happen.
Okay, I knew. Thank you, Leela, for.
He's the smart one.
Okay, well, he's the smart one, and you're the one that people like to talk to. And so it takes a team,
That's probably true.
I'm messing with you, Hunter. I'm sure you're a wonderful person to work with. But it does often take a team. You have people that are just better at a maybe a functional area. Like a finance person might be better at teasing out requirements from the finance folks and drawing up a data, but maybe they're not the greatest at all the formulas and formatting and whatnot. So yeah, you have an intermediary designer, and a lot of web development is like that. You have folks storyboarding user interface designs for a website, but they're not the guy that knows Java and Angular and CSS and all that stuff, but they know what's possible, and they know what the users are looking for and what the labels ought to be, and where to put in a graphic and where to put a next page thing, and they know how it should look to the user, what the user's experience should be. but they're not necessarily great at the widgets. And a lot of folks, I would put myself in this category. I may know how to make it work, but I have no artistic ability at all. If I design it, like you've heard me saying, oh, but that's making it pretty. I don't care. That's making a spreadsheet pretty. I'm not going to cover that. I don't care. It's it's a it's a weakness. It's a weakness in my toolbox that I just if stuff works, I think I'm a victim of heredity. I think heredity, genes, genetics. Um, my father would make things that worked like out in his shop. If there was some widget, something gizmo that we needed, dad could dad could make it. But they were rarely works of art. They were they were rarely pretty, but they were functional and all the other things, functional and robust, and inexpensive and all the other things that you would like. But there's that there's that good looking factor in there. So yeah, so I wanted to use this sales uh, um, table here, and we can and I want to do some of these tasks from start to finish, just so that you see it, in one segment. So I have managed to uh, yammer on about my father. I apologize. He died in 2000. Miss him. Um, until it's break time. So let's do that. Let's take a break. It's 9:15. Come back at 9:30, and we're going to go through wrangling this here data into a pivot table and a pivot chart, and slicers, and we'll see the effect of all of that. See it back at 9:30. Okay, we are back, and I wanted to walk through raw data to a table, to a pivot table, and adding a pivot chart and adding slicers. And then I won't talk about those again until we do our workshop and wrap things up next week. Wrap things up with Excel and move on. Okay. How was my audio that last? Did the Ethernet cable? So
Yeah, it was
yeah,
great.
there you go. I was a little worried that it would boot me, but I plugged in the Ethernet cable and then unplugged the USB. I thought maybe the two ports or protocols or whatever would boot me out of the Zoom session, but it worked just like that. Amazing when these things work, these computers. Okay, share the screen. Okay, and again, guys, I'm just using pivot table slicers is the file I'm working in. So you can absolutely do this sort of thing yourself. Like I said, all I did was make a copy of the sales tab that came with it, and then delete these slicers and pivot tables. So we had a row for month and a column for state. Okay, so let's go create that from scratch. What did we say? A row for month and a column for state. So we've got this data here, right? And it is not in a table. It is just raw data. So I like I said, I always convert it to a table because it seems to make Excel behave better. So let me see if I say insert without selecting all the data. If I just say insert table, it automatically looks for blank columns and blank rows, and it kind of figures out the contiguous data that you have, and automatically bounds the table based on the blanks. And then always, if you, there's a lot of places where you have to tell Excel that I have a header, which is the column name, so make sure if it ever comes up and it isn't cooperating, there's a lot of times that's the option that isn't working automatically. But of course here, Excel being as smart as it is, guesses that we have headers. Okay, so I'm going to turn that into a table. And then the first thing to do is insert a pivot table. And I could do recommended pivot tables. Let's see what the recommendation is. No, that's a chart. Recommended pivot tables. So I click on that and I'm seeing a row by region, but we don't care about region. We just want all the states. And then the next one here is all the states and quarters. No, that's not one. So it doesn't always pivot the way you would want. But this is a great data set to mess with pivot tables and subtotals and whatnot, because you have a region within a state that it can do double summarization of. But it's not, none of the recommended pivot tables are what I want. So I'm going to cancel out of that, and I'm just going to say insert pivot table. And I want to do it, I'm making like a dashboard here. I don't want my charts and my pivot table and everything to be in a separate worksheet. So I'm going to say put it in the existing worksheet, and go ahead, and it wants to know the upper left corner to put the pivot table in. Everybody doing okay? All right. So you can type in, I could type in G3 here, but Excel, virtually every time you're working with Excel, it lets you select the cell or range of cells and automatically plugs that in for you, kind of making it a little harder to make a mistake. So I'm going to click in G3, and it automatically puts in the worksheet name and the cell reference. So that's where I want my pivot table to be. And of course it doesn't know, I mean, it's a blank pivot table, so it doesn't know what to do. So, hey, Jim, can you mute your mic?
Yep, sorry.
That's all right. So we had month in the left-hand column. I'm trying to go by memory, right? Right? We had month over on the left, a row for each month. And then we had a column for each state, right? I'm going to go back and check. I hate having to look back and forth. Yeah, we had rows for each month and columns for each state. So since we have a column for each state, we'll drag that down to the columns. And now I have a column for every state. And then what's in the meat? What are we summarizing here by in January in Arizona? What? So what we're looking at is sales data. So of course we're going to drag the sales column down into our values, because that's what we're pivoting. That's what we're accumulating for every state and month, is that sum of the sales data. Okay, so that's a simple pivot table based purely on, one type of row, one type of column. Well, just real quick, you could, if you wanted to break it down by region as well, you could drag region down underneath state, and it would kind of automatically nest. Let's see what that looks like. So now we have is there only, oh, Arizona is in the west. Okay, yeah, I made a mistake, but I'll fix it. Let's look at it. I was thinking there were regions within each state. They're not. There's states within each region. So I goofed that up. But to fix it, all we got to do, I believe, is change the order of our columns, and I think it'll fix that. Yeah. So we have now all of our central states accumulated within one group, and then all of our eastern states accumulated within another group. And that correction was made just by reordering the columns, which depending on how the hierarchy lays out in your raw data, determines which order you would do that. Any questions on that? Everybody see how I did that, or how that worked? Region is superior to state. There are multiple states within a region, so the region goes at the top of your columns in your pivot table fields task pane. Okay, so we don't want to do that though. That's not what we're recreating what we had on their sheet. So I will get rid of region by simply dragging it back up here. And now we have what we worked on over here. But you'll notice this pivot table starts to get kind of cluttered, right? That this is not nearly as readable and useful as a smaller, tighter pivot table. So what we could do is insert a slicer, which I believe we have over here in our table that we're recreating. Yeah, we've got a couple of slicers here by state and by month, because that's all we're looking at is state and month. So see how nice and small this pivot table looks? It's the same pivot table as the one I'm working with in raw data. It just doesn't have any slicers applied to it yet. So I would go here, put some slicers underneath. Actually, let's do a pivot chart first. Let's insert a pivot chart. There we go, right in the middle. Insert a pivot chart. And its recommendation is a clustered column chart, which has the months and then the amount of sales by state, which seems reasonable. So let's do that. And I'll drag that down here and make it just a little bigger. But that's pretty cluttered, right? You threw that up in front of your leadership, in a boardroom or a conference room, they probably wouldn't get a lot out of it. So you can filter stuff here using the pivot chart, but you can also insert these slicers that are, I think, more user friendly is the main appeal to them. So let's insert a slicer, right? Yes, insert a slicer under the filters group here, and we want select a connection. This isn't what happened last time. Hang on a minute. Oh, duh. Gotta have your data range for it to be automagic. It needs to know what in the heck you want to insert a slicer to. So let's click in the pivot table and say insert slicer and see what happens this time. Now it knows the data that the pivot table is based on. And since we're doing month, we want to do month and doing state. And you'll notice your slicer can contain stuff that's not in the pivot table, because it knows, because the pivot table is based on this normal parent table. But since we have this in the pivot table and this in the pivot chart, state and month, that's all we're going to use for our two slicers. So we insert them. And of course, they're floating on the top on this drawing level, just like the chart is. So just like a chart, you can drag them over here and put them where they're starting to look more like an interactive dashboard. that an executive could use to actually, slice and dice the data according to their own desires. So by default, because we didn't have any filters applied anywhere, it automatically picks up all of our states and all of our months. But just like I showed you before, you want to filter this stuff down, this clustered bar chart. That's too many states. So I want to start, maybe I want to look at top performers or something, so Oklahoma seems to be doing pretty well. So let's click on Oklahoma, and I can select as many or as few as I want. And right next to Oklahoma, maybe, what do we got? Isn't Kansas right above Oklahoma? Oop, I didn't hold control. Clicked on Kansas without holding control. So it unselected Oklahoma. So if I hold control and click Oklahoma, now we get both of them. It takes just a second for it to react, but now you can start to compare self-service, and you as the analyst haven't had to do anything except design the user interface, design the worksheet. And if, by chance, I just want to look at the first quarter of the year, yeah, these are in alphabetical order, which isn't as useful as 01, 02. But January, February, whoop, hold control. And it takes just a second for it to react. I don't know if you're following along here, you'll see there's just a little lag between holding control and it activating.
The little checklist button next to the filter toggles multi-select on and off too.
Ah, thank you. See, there you go. You got ahead of me. Multi-select. Ha! Was that Leela?
Yes.
Thank you very much. There you go. So we can do multi-select, so you don't have to hold control like the dinosaur Dawn. So yeah, and you can see that it's activated because it turns yellow. And so what's the automatic filter looking button there? Clear it. Bam, bring them all back. There you go. Okay, so that's that's a raw data going from columns and rows into a table, converted to a pivot table with different factors, a pivot chart based on that pivot table, and then data slicers, pivot table slicers that help you filter the data a little bit more, I don't know, elegantly, user-friendly looking. Okay, and that's pivot table slicers is the name of that file if you want to goof around with this stuff. Any questions on that? Okay. So if we did an Excel exercise homework, and I were to say, given this data, create a pivot chart that summarizes, for this one, that summarizes sales by state and region, and include a stacked bar chart that reflects sales amounts. And if I were to give you an assignment like that, do you feel like you're equipped or close to equipped to turn in something like that? What do you think, Dave?
Most likely.
Yeah.
Okay, cool. And yeah, and you guys that are doing this stuff all day, every day, hopefully you're not too bored. But we'll go through this Excel stuff again next week, a little more methodically. Because this has just been a no hands-on, just a brief tour of the generic things that you can do in spreadsheeting. A lot of this, no, I wouldn't say all, but a lot of this is you can be done in Google Sheets. Not quite as powerful as Excel. Some might say not nearly. And you can do a lot of this in Python. You can create a dashboard like this in Python, and you can do it in Power BI. So that to me, that's where your comfort level, my comfort level goes up when I start to see this stuff being done in multiple ways with multiple tools. And you start to think, oh yeah, that's nothing new. I saw that in what you call it. And it's just a matter of figuring out how the tool does it. So there you go, pivot table slicers. I am gonna move on to our final basic, well, that's probably not the right way to say it, to our fourth basic Python notebook. So if you haven't already, if you'd log into the classroom, I'm going to put away some stuff here. If you would log into the classroom and download Notebook 4, where was this at? Must be in my downloads. Sure, save it. Okay. And then there's my bank accounts. Put that away. So yeah, download Notebook 4 and put it in your Python notebooks folder and get ready to follow along. Or of course you can just watch me. Oh, that switching the X and the Y axis. Man, I saw that somewhere where it's like you click the box and it just worked. But then I do remember spending, I don't know, half an hour, an hour. In some, it's not that easy. It seems to me that the easiest way might be to just reorder the columns, to just take what you had in column 1 and column 2 that you drew your scatter plot with and switch them. But this is a way to do it within the chart so that you don't have to change that data. But it's complicated. It should just be a button. But it's not. It's like you got to go in here and format and cut and paste stuff into this dialog box, and you can't just say switch column and row. Anyway, I need help working on that. Adding data to a chart after you've created the chart is something that I'm not particularly comfortable with at all, and I need to get better on that. Maybe next week during the workshop. So anyway, I was unable to find the easy mouse click that I could swear I remember running into. Get rid of that. Get rid of that. Okay, enough yapping, y'all. Should have been able to download that file out of the Python modules. 04, repetition statements and looping. And I went over this one over the weekend, so I don't think it'll break on me, but you never know. We may have to fix something. So we're going into, of course, we've selected Jupyter Notebook off of our start menu and gone down to my OneDrive, Documents, Python, down to Notebooks. And now I've got a whole lot of clutter. I really need to clean this up. I got too many notebooks here, cluttering things up. But repetition statements, aka looping, is what I want to go into here. And I almost certainly will not get done by the first break here. But I think I'll get done by the end of the third hour. Okay. Repetition structures. So we've done sequential statements, and they will execute one time every time. The computer doesn't check anything. It does that that command, a print or an assignment statement, or you could open a file or close a file or write out to a file or read a line from a file. But if you don't put any conditional statement in there, like the if, elif, else that we learned, or a repetition structure or a loop in there, it just does it one time. So very often you want to loop through, and that's it. Loop just, it's just like you'd think, like if you splice a an audio file and run it, and over and over again, it's on an endless loop. So that's the same same structure, same concept. But you are in control. It doesn't necessarily, it's not an endless loop, hopefully. you write the logic as the programmer that makes it loop or makes it endlessly loop. And it's almost always going to happen. So we'll get into that a little bit. So there you go. That's what they're kind. And there's two kinds of loops. Like what Excel is doing in the background when it creates a pivot table, I would bet money, because that's how Python does it, is looping through the data and like through the rows and accumulating sales every time it loops through a row and sees, California and month equals June. It has a little accumulator where it's adding up the sales and sticking it in the pivot table. That's what a pivot table does. Really, at the click of a mouse, is loop through the data and summarize things for you. But as a Python programmer, you need to do that yourself frequently, not all the time. We'll get into that with these analytical libraries. Some of these things do the loop for you, like a pivot table does in Excel. But like last class, I helped some folks loop through some data that you had to inject your own logic. The logic got a little too complex to just do a one-line statement. Okay, so you've got two, just generically in computer science, you've got two kinds of loops: condition controlled and count controlled, otherwise known as a do while loop or a while loop. There's a lot of computer languages out there that use different syntax for it. But what it does is kind of like an if then else, checks a logical statement. If A is greater than B, and it does that leg, a while loop is pretty much the same. It just comes up and checks it again, because somewhere in your loop, you got to do something that changes this condition somewhere in there. Otherwise, it will be an endless loop. If nothing ever changes if A is less than B, if you never change the value of A and B, and it's always A is always less than B, then it's going to do that while loop over and over and over and over and over again. So that's what I say, as the programmer, you have to put in the logic, and we've got numerous examples of that in this lesson today. So we'll do that one first. We'll do a conditional loop. And you can use all the same logical operators that we covered in that conditional statements and Boolean math. All the same. You can use the not keyword. You can say if something is less than something else, while something is greater than something else, while something equals something, while something doesn't equal something, it will do that loop, and you decide on the condition. Okay, so we got an example here. That's always, to me, that's always the best thing. So one thing to remember is, as your program is executing, the while condition is tested before it ever does the loop. So it won't do the loop and unless the condition is true. There are other programming languages where you can write, I know in Pascal, the language I learned, and you could do a repeat until loop that always did the loop one time and then checked at the end to see if it should keep doing it or do it more than once or whatever. But a while loop always tests before it executes the first time. So it's they call that a pre-test loop. Okay. So if the condition is true, all the statements in the block of code within the loop will execute. Okay. So we got a pretty simple example down here to go along with. So this is calculating like an amortization table or whatever, like how long does it take to reach a target value based on an initial deposit. So real simple. And then we just we increase the balance by the interest rate. You know, we multiply our balance every period, every year, and add that interest to the amount, and then it grows and it grows. Compound interest, magical principle of investment. So let's see what we got here. We've got a few, 1, 2, 3, 4, 5. We've got 5 sequential statements, right? Just like those are going to execute every time this code cell, this program executes. And then we pop into a while loop. Okay, so there's a couple of things that I'll point out while we're goofing around with this. So while our balance is less than or equal to our target is where we want to get, say, to retire, and balance is your initial well, it starts out as your initial deposit and then grows based on the interest. So balance will grow within this loop. That's key. That's, remember back when I was talking about, you write the logic to make sure that this while loop is eventually false and will eventually terminate. So what we got here is our initial deposit and how far is in deposit. We've got an input statement to our target, and then our interest rate. And then as the years go by, we are adding 1 to the number of years, so we know how long it took us to get to that that target. So let me run this a couple times with some different data. So hold Control, press Enter. So our initial deposit is, say, $100, and I need to get to $1,000. See what that happens. And then a typical interest rate, and if you there's no error checking here. If you enter garbage data, this whole thing will blow up. So, but for the interest rate, what's the typical rate of return? They tell you to plan on 10%, right? So that's 0.1%. Let's see how long it takes us and how that amortizes out. So we want to get to $1,000. So you notice inside the loop here, I'm increasing the balance by the previous balance times times 1 plus the interest rate. So I'm multiplying the balance a little bit every year, and then there's, oh yeah, let me back up here. There's 2 ways to say equals something equals. Years equals years plus 1 is the same as this years plus equals 1. I think I might have covered that back in mathematical operators and whatnot. I personally never use this, but C programmer, anybody that's taken a class in C, a lot of times will really like that plus equals. Just to me, being old, learning to have programmed 100 years ago, years equals years plus one makes more sense to me, but there you go. Python takes both syntaxes. And then it prints out inside the loop here, this stuff, these 4 lines, actually it's 3 lines of code and a comment, are executing every time you go through the loop, which is checking to make, checking until balance is no longer less than or equal to target, at which point it pops out of the loop and moves on to the next thing. And you'll notice a couple of factors here, just like your if then else. You've got a colon at the end. You've got indenting. You indent the block of code that is controlled by the while operator, the while condition, and then afterward we put a blank. So at the end here, yeah, this 25 is just reprinting. We've already printed years and balance, so that just shows you that we've done it again outside the loop one final time. So that's how that works. It's incrementing the balance a little bit. This it was 110, then 121, and you see the power of compound interest. At first, it's it's only 10%, but then 10% of a bigger amount is a much bigger amount. So we start off earning $10 a year, and by the end, we're earning almost $100 a year. So woohoo, compound interest. Save early and save often, kids. So I wanted to show you something else about this. Oh, I want to run it again. Any questions on reading this? Is this, when you see it, it's like learning a foreign language. You understand it. Normally you can comprehend a foreign language listening to it long before you can make your point, and speaking the language and using the language to create something. But on the listening side of things, on the understanding the principle, any questions on what this while loop does or how it works? You would tell me, right? You would. We're all friends here. Looking good, Jim?
Yeah, this whole mute thing is getting me. Every time I hit the space bar, something else on another screen goes wild. So
Ah, yeah. Windows.
yes,
So
Windows.
So I wanted to run this again, and I don't think there's anything to keep me from doing it this way. Entering an initial deposit, say I deposited $1,000, $10,000, $1,000. Okay, and my target is $900. Enter interest rate. We'll use the same interest rate, 0.1. Bam. Years is 0. That's all it prints out because you set years equal to 0 up here. You enter data that was never true. Balance is what is your initial deposit. That's how it starts out, right? Your balance starts out as your initial deposit and then grows based on the interest. Because I put in that data, balance was never less than or equal to target, so it never did the loop. So that's where they call it the pretest. And you'll, as you're writing programs and doing the logic, there's times when you don't necessarily want it to execute the loop, and you, like I said, you are responsible for the logic. Okay, so just like said, the while loop needs to contain a way. This is the next markdown cell here. The while loop needs to contain a way to make the test condition false. You have control over, in this case, balance and target. If you don't do something in the loop that will eventually, cause that condition to be false and for the loop to stop, you'll get an infinite loop. And the way you see that, or a sneaking suspicion, it's not always an infinite loop, but you'll see the asterisk in, see where we have next to the code cell, you've got in and then square brackets and 2. That's the number of execution of that cell. It's the second cell to be executed in this notebook. While the computer is working on it, while Python's working on executing the code, you'll get an asterisk in there. And sometimes that asterisk can take a little while, like you'll see when you're importing a library. Sometimes it's a lot of code to go out there and read, and it's got to go out to the hard drive and open it up and read it in. And it can take 10 seconds or so, depending on how many libraries you are importing into your program. And it'll asterisk for a little while, but that's not an infinite loop. But when you're working on something like this and you do have loops, that asterisk is the indicator, the symptom maybe that you've got a looping problem going on. So generally you can hit Control C, or it seems like you can hit stop to interrupt the kernel, and then you can restart the kernel. Hampton and I did that yesterday. That seems to work pretty well. If Python gets confused, you can stop the kernel and restart it, and it goes and you're back to scratch, So yeah, you have control over the while loop. And I am sure if you're anything like me, it's doing some brain teasers, and I will do a Python problems 2, not next week, but the week after. Okay, so that's a while loop. It can execute once, it can execute 0, it can execute 347 times. The programmer controls, and the data, of course, controls how that loop operates and the conditions. But then there are many other applications, many times, when it's a finite number of loops. You want to do something as many times as maybe the user has said. How many times do you want to do X or Y? I want to do it 6 times. So you catch a variable, you input a variable that controls how many times you do something. Or it could be the length of a list of items. You want to loop through that list of items. Well, that's a finite number of things. So that's another application of a they call it, it's a for loop in every generic computer science sense I've ever heard it. Although Mike's a better computer scientist than I am, and he calls them a count controlled loop. So there you go. That's even more generic, but everybody calls it a for loop that I know. I mean, in my experience. So for loops can get a little, you'd think it'd be easy, do this 5 times, can be pretty simple, but the way you work with them can get almost more complex, because the while loop is a Boolean expression, just like the stuff that we did in if then else. It's the same syntax. You can have, while this or that, just like we did in the if else exercise. A for loop generally speaking, does something a limited number of times, but you have to tell it the 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 range of times to do something. So I'll stop talking about it and show you. So here's an example. We haven't gone over them yet, but Python has a data type called a list. If you've done any programming before, generically that would be thought of as an array. It's just a list of values. So this is a Python list. So we want to iterate or loop through that list and then quit. So here is the syntax for doing that sort of thing. For item in the list, and for and in are keywords that you see how they're kind of in green in your notebook. That lets you know that those are Python keywords. Item is just a variable name, and I don't know where or why it's been this way since I got into programming in 1988. General convention for a loop variable, particularly a for loop variable, it isn't used for anything except going through the for loop. We very often call that I. If it's a counter, like for I equals 1 to 5, and then I equals 1 the first time you go through the loop, and I equals 2 the next time down to up through 5, people use I a lot as a loop counter. And if you're doing a loop within a loop, you'll see J. And you only do that when it's just a loop counter, because remember, you got meaningful variable names are important. But you'll see that convention as you work more with programming languages. Okay, so for item in 1, 2, 12, 9, 4, since it's iterating, beg your pardon, guys. Chilly out there this morning. The way that this particular type of for loop works is that item will be assigned the value of the thing in the list, not the number of the thing in the list. So there's 5 items in the list, right? Since you're using a list, it will do it 5 times because there's 5 things in the list. But item is actually being assigned the value in that list. So the first time it goes through that for loop, item will be 1, the next time it'll be 2, but then the next time it'll be 15, and then 9, and then 4. Because you're iterating through a list with a for loop, that's just the way Python works. So we'll execute that one, 1, 2, 15, 9, 4. So it goes start to finish and loops through that list of things. And your loop variable is the value in the list. And a list can have multiple types of things. So let's make one a string of howdy. And then you loop through and 1, 2, howdy, 9, 4. Because you can mix and match data types within a list. They don't have to all be the same. So that's how a for loop works when running through a list. But generally, you want to do it a number of times. And you're not running through a list of things. You're count controlling the loop. not based on the number of items in a list, but based on logic, that you want to do something, 20 times or 21, or or you can do it backwards, 21 down to 1. We'll run through all that kind of stuff. So it's break time. There is a special function that I learned for the first time in Python called the range function that controls the range of a for loop, or it's a function that returns basically a list of numbers within a given range that then you use to control your loop. So let's take a break to 10:30. Yeah, let's call it 10:30. When we come back, if you have any questions, don't let me get started again without taking questions, please. Remind me. Okay, we are back. Sorry for the delay. Questions, guys, on, let me share my screen again. Oh, that was something else. I want to show you where we're going. Yep, not there. There we are. The controls for Zoom getting away sometimes. Okay, so looping. Did I gloss over anything that you want to slow me down and ask a question? Clear as mud till you start using it a little bit, maybe?
Clear as mud until we start using it. Yep.
Okay.
Yeah, I think that's just the nature of programming.
I think it is. Practice, practice, practice. Till you start doing something hands-on and making mistakes and then correcting those mistakes. I agree. So the one of the primary ways of controlling a for loop is to use a function that returns a list of numbers that you then use to count your number of times through the loop. And the range function is fairly simple, but it can get a little more complex. So the range function takes arguments that you tell it, like how many times you want to do the loop. You tell it, where to start and where to end. Sometimes you don't want to loop necessarily from 1 to 10. Sometimes you want to go 10 down to 1, and you control all of that by passing the correct arguments or parameters to the range function. Now we get into a Pythonism that is, for some folks, it's just natural and it's the way it ought to be and everything is great. For me, it's something I have to constantly remember and think about, and that is the way Python handles ranges of values. For example, the range function starts at 0. If you want to do something 6 times, like this first bullet on your screen here, if I want to do something 6 times, I pass a 6 to the range function. And if I have a counter, for loop counter in range 6, it'll do it 6 times, but loop counter will be 0 the first time, not 1, which I would expect it to be 1, 2, 3, 4, 5, 6. That's intuitively, that's what I expect. That's just not the way Python works, and I believe R is the same way. And so for a lot of people, making it 0 based makes all the sense in the world. I think particularly for true scientific sort of endeavors. So it's just something to remember. the first, if the first parameter is the number of times through the loop, but if you don't tell it anything else, it assumes that you're starting at 0. And then if you give it a second parameter, that's the ending value, not up to, but not including. So range 5, 11, and like I said, yes, once you start using this and doing something one less time than you intended to, or doing it one more time than you intended to, this doesn't make a whole lot of sense. But yeah, range 5, 11 means start at 5 and loop up to but not including 11. So the range function is 0 based, and it's there's a name for that. It's exclusive as opposed to inclusive. Up to 11 exclusive. So it excludes 11. So yeah, range 5, 11 will loop through. And if you say, like, for loop counter in range 5, 11, loop counter will be 5, 6, 7, 8, 9, and 10. Okay. But then this third parameter, you don't always want to increment by 1. There could be applications where you want to increment, even you increment by 2, or maybe even incrementing by 3. And then, so we'll take a look at this. But these numerals in here, 6 and 5 and 11 and 2, 11 and 2, those can be variables. Those don't have to be numeric literals. So you can have a lot of control there with the logic that you write. Let's see what my buddy Mike has to say. You can use the target variable inside the loop just like any other variable, keeping in mind that it changes with each pass through the loop. Yeah, but that is often the point of using the target variable. So yeah, just like up here where we said for item in this list, inside of this, inside of the loop, you can use item. You can say, if item equals something, do something. You know what I mean? So item is a usable. You can set another variable equal to item. One thing you don't want to do is set item equal to something inside of a loop, because the loop is controlling the value of item. So you want to avoid making that mistake. Okay. Often, the hardest thing about looping is figuring out where calculations and other actions should occur in the loop. And yes, and I've seen that with myself and helping folks, is doing something outside the loop or doing it inside the loop, accidentally putting something in the loop, accidentally forgetting in a while loop to put the logic in that gets it to ever terminate. So there's, yeah, this is where it's getting to be somewhat complicated. All right, so here we have an example for loop where we are looping through 12 times, and we're oh yeah, this little programming exercise is just kind of as it oscillates between, as prices increase, production increases, and that causes a drop in price because you overproduced, and then back and forth until it reaches equilibrium. So that's what this algorithm is doing here is under the example here. See this this markdown cell? It shows the algorithm, but that's what it basically does. Is as prices increase, people overproduce, and then that causes overproduction, and it oscillates back down the other way. And you'll see when we run it here, it goes up and down and up and down and up and down until it reaches equilibrium, or it finds a perfect balance of production and price. Okay, so this thing sets a quantity. You put in the quantity, you put in the year. It prints out that stuff as at once as a header. So you'll see that one time, and then you see the output of the for loop underneath that line, kind of like column headings. So for num in range 12 is going to this range comma 12 is going to return a list of numbers starting with 0 and ending at 11. So it's going to return a list of 12 numbers starting with 0 that will go into num. And then it starts at 0. The first time you go through here, num is 0. The next time you go through here, num is 1, and so on until num hits 11, and then it stops. So we're setting price equal to 20 minus 10% of the quantity. And then we print out each time through the loop, we print the year, a blank, the quantity formatted as a decimal, and then with 1 decimal place, and then price formatted with 2 decimal places. And then we increment year by 1 because we're inputting the start year like 2019 or whatever, and we increment it, and then we set quantity equal to that price that we're calculating up here, and then do it all over again. So that's where they get the oscillation. Okay, so we'll hit Control Enter on this one. Start quantity. We're producing, it's in millions of bushels, right? Yeah, suppose it's 80 million bushels. So we'll say 60 is our first 60 million bushels. And the start year we'll say was 2010. Just an example. That doesn't look right. Did I do something too low, or 20 minus 0.1, or is it too big of a value? Seems like I've had this problem before. Quantity like 4? Trying to remember what it's looking for. Yeah, there we go. I think 60 might have been the equilibrium point by just by coincidence. Let me run this again. So if we produced 50 million bushels and starting in 2010, yeah, we produce 50 million bushels. The price is 15. So the next year, because the price was so good, we produced 65 million bushels, and sure enough, price went down because we overproduced. And then because the price went down, we dropped production, which causes the price to go back up. And here's, sure enough, I happened to pick the equilibrium point in my quantity. But once you get to 60 million bushels, the price stabilizes within that algorithm. It's very simple. I mean, it's simplistic. The price stabilizes at 60/40. So you could actually do something this like a while loop. You could, instead of doing it for 12 years, you could do a while quantity is still shifting. You could do the old quantity, new quantity, and kind of check like that. And then once it reaches equilibrium, you check that change and go, oh, seems like we're at equilibrium. Nothing is changing, and you pop out of the loop. And I think we do that here in just a minute. So that's a for loop. It returns a list of numbers based on the parameters that you send it. So I want to play around here a little bit. Go off script. So if I click plus in here, I want to add a cell to goof around with. So I just click the plus sign and I get a new cell, and it defaults to a code cell. You can see in the drop-down menu here, it says code. So now I have a new cell. What I want to do is hopefully this works. I want to show you what the range function returns. And just like if I type in year here and hit enter, I get whatever year stands for right now. Remember up here in this code cell, we were incrementing year by one, starting with 2010, and then we printed it out, and the last one to print out was 2021. Well, apparently somewhere in here, it incremented it to 2022 before it printed it. I guess, oh yeah, because we increment it after we print. So after we printed this line 2021, we increment the year again, which may or may not be useful. So anyway, that's how year got to be 2022. Okay, so remember, you can type in just the name of a variable, and you get it's like printing it. It puts it out there to the output. Just like, remember, you could say, 1 equals 1, and that's true. So you can put an expression, and Python knows that you're just looking for the result of that. So what I want to say is that we can do range 4. And if I just hit return, I haven't practiced this, I'm going off script. I believe it's going to show you a list starting with 0 and ending with 3. That's my prediction. No, it's just showing you the parameters. I was thinking it was gonna maybe, hang on, stick with me. Stay with me, guys. Maybe that's what I know I've done this. No, that's not it. I could swear that there's a way to show what the range function is returning, but apparently not. So I'll go back to my script. So if you have a cell that you don't need, like I don't need this code cell anymore, you come up here and you just hit the scissors and it'll cut that code cell out. Okay, so we can use an upper variable. We can use an upper limit variable. So here is the exact same situation, but instead of hard coding this 12, we can use a variable inside of that, and that's all that does is replace a hard-coded number with a variable. So it will loop through as many times as you want it to as a user. So let's do the exact same thing. Control Enter. Start quantity. We did 50 before. I think it's the same math. Start year was 2010. How many years? How many years? Let's go 15, but I think it's going to reach equilibrium and repeat. I think. Yeah, see that we get down here to 60 million bushels and $14, and we have the same equilibrium we had before. But this time you are telling the for loop how many times to, for the range function to return however many you have told it to do. And I wanted to show you that you can, this is using this num, this range variable, starts out at 0, goes to 1, just like we talked about. So that's a good thing to remember, and a technique I use all the time is called a diagnostic statement. It's a print statement. When you start getting into loops and ifs and then nesting them within each other and looping X amount of times, and inside of that loop, if that, and it starts to get a little complicated. And the only the only real way to get visibility into all of that code executing is to put in a diagnostic statement that kind of lets you know where the program is doing what. And you can kind of see what the value of variables are. I will even put, print, I am inside of the second for loop or whatever the case may be, so that I can have visibility into what's going on inside the loop. So that's really what this shows you is sometimes you're not sure of the logic, so you can put a diagnostic statement in there to print out to the screen what's going on. And if I comment that out, cleans up the output somewhat. So you get rid of you comment out your diagnostics or get rid of them altogether. 2010, and how many years? Let's say 6 years. Cleans it up when you take your diagnostic statements out. But it can be, those are super helpful when you're doing a programming exercise or writing an actual program. Okay, so that's simple concept. Putting a variable in for the number of times through the loop. But you can also go backwards. Remember the last number is your increment variable, but can also be a decrement variable. So you can go, and actually in Pascal, I want to say the syntax was for I equals 20 down to 1. So you would actually, there were keywords that did that, as opposed to using a function. But this is how you loop from 10 down to 5 exclusive by 2s. Okay, and here for I in range starting at 10, ending at 5, decrementing by -2 instead of incrementing. So let me see how this runs. Y'all running this along with me?
Sure.
So you can, you guys can go into these. If you ever mess up one of these notebooks, you can always just re-download it. So don't be afraid to play with these. Let's make that 30. And you'll notice it stopped at 6 because it's exclusive of 5. But let's say 30 down to 6 by 3s this time. Maybe we're doing something with, I don't know, with triangles or something. 30, 27, 24, 21, 18, 15, 12, 9. But it can't do 6. It's exclusive of 6. So that's why it's decrementing by 3, but not including 6. So it's looping from 30 down to 6, not including 6. Okay. Few more general computer science terms to go over here. Let me see how much more I got. Yeah, let me finish this up. Okay, so accumulators, counters, and sentinels. These are generic computer science terms for variables that you are using in your loop to do different things. The counter is, of course, the loop counter. But you'll see sometimes when you're going through a loop, you want to accumulate values as you go through the loop. And then sometimes a sentinel is something that you would do logic with, like a sentinel is a guard, something that is looking out for something else. So those are 3 types of variables that you're using within your loop. And I mean, that's the computer science 101 explanation. When you're doing these, you'll just kind of figure it out. But it really does help to see these for the first time. Actually, I'm in a for loop. The counter, no, it's not necessarily like item. It's not the counter is not necessarily the loop counter. A counter is no kidding how many times you've been through the loop, but the loop variable isn't necessarily 1, 2, 3, 4, 5, 6. Remember it up here in the our first loop. It was howdy 1, 2, howdy 9, 4. That's not counting the number of times through the loop. So a counter is something you can rely on that tells you how many times you've been through the loop. There, more accurate. Okay, so this little code block prints out, calculate a total for a number of items entered. And then, yeah, max is how many items are we going to calculate. So this is just going to add up. All this is doing is adding up a finite number of things. Okay, so let me see what we got here. Our accumulator in this is our total, because we're going to go through this however many times I tell it. Whatever max is, it's going to do that loop max times. But this count variable counts the number of times through the variable. That's your counter. And total is going to accumulate the cost of these items. And then, of course, count plus equals 1, count equals count plus 1, however, whichever one makes you more comfortable. So we'll run this and say, I'm going to do 4 items. Enter an item cost, 4, 5, 7, 3. And it did it 4 times. So the total for those is $19. So yeah, you can see how total is accumulating stuff through the loop, whereas count is just counting the number of times through the loop for 4 items. And those can be more useful. Like I said, when you're doing a for loop that isn't necessarily, 0 to 3, like it was in this case, they can be more useful. Okay, clear as mud until I get to use it. Okay. Yeah, here's that. Yeah, x equals x plus 1 can be written as x plus equal 1. Whichever you're, that's less characters. And it makes perfect sense to some programmers, particularly C. But yeah, plus equals, multiply equals, divide equals, and mod equals are the same thing. It's just a more brief assignment statement. Okay, and then now we're going to use a sentinel, which is really only used in a while loop. I want to say there's a way to break out of a for loop before doing it the number of times that you said you wanted to do it. But I don't, that's not structured programming, generally speaking. So I'm not a big fan. So generally speaking, you want to use a sentinel to pop out of a loop. So we're going to go back to the while loop, and we're going to take a user input until the user enters a sentinel value. So we're going to ask the user, enter the cost of the thing, enter the cost, enter the cost. And when you're all done, a sentinel value is something that you would never need as actual data. So we're going to loop through this, and we're going to ask the user to input an item cost. And while the user does not put in -999, notice this is outside the loop. So that primes it for the first pretest. So then if the user did not enter -999, we're going to calculate, we're going to total this stuff. And then inside the loop, we ask them again the exact same thing, enter an item cost. Because if you only ask them once, and you don't ever give them a chance to enter a new item cost, this item cost will never, change. And yeah, so you program in the logic, and then we pop outside the loop after I enter -999. We pop outside the loop and print out the result. So item cost. If I say -9999 the first time, it prints out. It goes straight to the print statement. Never does anything else. It never executed the loop. Let's try that again. So I'm saying and I keep going and I keep going and I keep going and going and going and going until I enter the sentinel value, -999, which means I'm done. Now add up everything I've done. So that's how that works. And sometimes the sentinel value is a user input, but it can also be something that gets calculated down in the loop. And you just got to make sure that the data will support that calculation that will eventually cause the sentinel value to be false, the sentinel condition. Okay, so that's another while loop. And then you can nest loops within loops. So this is just a cute little example of a star pattern, or that will repeat for a number of rows, and then it adds a star as it goes down a row, adds a star. So we've got an outer loop that's controlled by I, starting with 1 and going for the number of rows that I input plus 1, so that it will actually do the number of rows I input. Remember, the range function was exclusive of that second number. So I actually want it, if I put 4, I want it to go from 1 to 4. I don't want it to go from 1 to 3. So that's why you add 1 to this second number. And then inside of that for loop, we're going to execute this for loop where we're going to control J. The outer loop is counting rows. The J is counting whatever row we're on plus 1 to give me one more star on the row we're on. And so it increases the number of stars across the rows as you go down, and you'll see just a minute. And then we want to print on the same line. So I believe we've already covered this end equals character. We want these stars to print out inside of the for loop. We're not building like a variable that has 1 and then 2 and then 3 and then 4 stars. We're printing them out inside of this for loop where J is iterating. So you got this I thing, and then you do the J thing X amount of time, and then you come back to I, and then you do the J thing inside, and then you come back to I, and then you do the J thing, each for however many times it makes sense. And then we finally print a blank line which is inside of the outer loop. So here we go. So I want 7 rows. Bam. So the first time it goes through, it prints 1 star inside of here. I is 1, so it prints it prints 1 star, and then the next time it prints I is 2, prints 2 stars. So that's nested for loops, which do come in handy. I know. Clear as mud till you use it. So an input validation loop. Yeah, this is where you start to do data validation. So in here, we're saying if they enter a negative number, basically, go into a while loop so that they enter a deposit that is a positive amount. And there's any number of things that you could do like that. And all this is doing is that same investment math that we did before. But it's showing you that you can do an initial prompt, and then you error check it to make sure, like in this case, to make sure it's more than $1. Okay, so let's run that, see what we get here. Enter deposit, -5. That's invalid. Enter your deposit. -10. That's invalid. Enter your deposit. Okay, 1. Yeah, because the condition is less than 1. Where it says it's invalid. But since I entered 1, there you go. It works. So my target is 5, interest rate 10%. Whoa. So it only takes me 17 years to make $5 after I put in my $1. So that's how you might validate a menu where you would continue. You wouldn't just pop out like in the if else elif discussion. We did a menu of options, like a telephone menu. Press 1 for this, press 2 for that. If you put that in a while loop, it'll keep doing it until they press something that you want. And the same thing is applicable when you're not using user input, but you're actually parsing through data itself. I did want to show you just one project I was working on with somebody else. So all this does is read in a CSV, and then here's an example of nested for loops. We had to do a for loop to range through the data, and again, this is using a data frame, so it looks like a spreadsheet. So we had to loop through the data by row, and then loop across in columns, and then do some if then else logic based on the column value. So you've got, nested for loop, and then another for loop to loop through some other stuff with nested if inside of it. And then you see I've got diagnostic statements here, so that you can see what's going on. This was an interesting project, but it's kind of giving you an idea of where we're going when it comes to code. And this was pretty advanced if you haven't coded before. But for folks that have some programming experience that are learning Python, it's just a matter of learning the syntax, how Python does what I know can be done. And that's the battle everywhere with all these tools, is I know it can be done. Which button do I click on, or what's the command for it? So anyway, there is a reason for learning these things, because that was an analytical exercise, finding out the value of a new email account based on following subsequent events. Okay. Other than using this, any questions? Is there anything I glossed over that you don't want to stop and slow me down and okay. Well, I'm about spent. I think I've given you enough stuff to goof around with here between Excel and Python. Like I said, feel free to change these values in these notebooks. And if you ever get, you know, um, paint yourself into a corner, you can always re-download them. But I'd encourage you to practice with these things. If I glossed over stuff, read the notebook, read the markdown cells. Next week, when we reconvene on Tuesday, it will be for a two-day capstone intermediate Excel workshop. And then when we come back from that on the on the 16th and 18th, the week before Thanksgiving, we're going to start working with some SQL. Is anybody having trouble getting SQL Workbench installed? Any pushback from your silence? Means you've got it installed and it's no problem.
Well, it's installed. I'm not sure about problems yet, but it's installed.
It's installed. Okay. No, it's as long as your work let you install it. Generally speaking, I haven't ran into a firewall problem yet. It uses a pretty standard port. But we'll do a check on that sooner than later. I've got my database loaded up. Okay, guys. If there are no questions or concerns for me now, if you want to get together offline, let me know, and we can get together and do some one-on-one tutoring. I'm happy to help.
Can you mute yourself?
Can I mute myself? I didn't catch that last question.
I'm not hearing anything. Can anybody hear me?
Yeah. Yes, we can hear you.
Yeah, I can hear both of y'all.
Let me put that in the chat. So there you go. Let me know if you need help. More than happy to meet one-on-one and get you over any stumbling block you might be seeing. Other than that, let's reconvene Tuesday and Thursday next week, and we'll finish off data analysis with Excel.
Yay.
Yay! Happy lunch, everybody.
Yay.
Thanks. Y'all have a great weekend.
Thank you.